All right, wonderful. The topic today was very much, David, are you here at the moment? Do you like to give a short intro about what's our today's topic?
Yeah, let me just leave the noisy space behind. So today's topic, as we already introduced last week, I hope you guys can hear me well. I'm really trying hard. Um, last week we spoke about RChain and kind of all the mechanisms that may or may not be involved in being able to realize a token, and we wanted this week to move into what a token actually should look like, could look like on RChain. And this is what we're going to be talking about today in the main session. If anyone is interested, and I think as we have that in the protocol, we should also stick to that, is taking a look what everyone has been working on, and as already happened when people are still joining in, collect further interesting topics for the backlog. So like I said, I don't have visibility into the minutes, but we already, I think we already collected two new topics. Tim, can you tell me what it was?
The topics last week, the backlog of the minutes?
No, the ones we just collected right now. One from Glen, that was about just, storing data on the blockchain or on, and several ways to do that. And there was another one, wasn't there?
We have storing similar on the topic, and I just spoke about a thing we spoke last week about as well, was like introduction of the RChain registry, because it's kind of interesting to know how we can utilize the interface, user interface, to speak with the smart contracts. Yeah, I think those two topics. Are there any other topics? Maybe we do just a short, quick round where everybody can introduce like his current project, what he's working on, and where he likes to maybe have a spot on, so that we have a backlog for future calls or potential topics we can speak about next to the main topic from Theo today.
Mm-hmm. Not too much.
Hey, Glenn, do you like to start and share what you're working on right now?
I'm sorry.
I mean,
nice of me to. I'm not prepared to display. I can only just speak philosophically. Well, very quickly. Let me. Just 1 second.
Sure. Maybe somebody else likes to start. Okay, wonderful. Yeah, we can see it now.
Okay, so I'm just going to show that this was from just a discussion in Discord. And so I'm trying to just be able to store a fact on RChain. And so I said approach one is to do a double persistent send, and then here's the data. And from an application, I mean, this is terribly simple, so I'm fine if people say, yeah, we have this figured out. It's just that it seems, I don't know, I had to ask myself if this is a valid approach and how you would use it. So again, the capability that I'm trying to achieve is that I could tell any of you that it has been stated X. And I'll see if I can, I'll turn my video on too. You can. So does this make sense? Like that I'm saying it has been stated, whatever this data is, that the reason we would, the value we get is that I can point people at the history of RChain and say, look, this statement was made.
Hi, Joshy. Thanks for tuning in. Just to give you a short here where we are right now. We do a short introduction. What are the topics people are interested in before we start with the main topic, short introduction. And Ken was speaking about that he would like to show the ability to store data and show and hint to that data, I think in the form of immutable record. Is this correct, Glenn?
That's right. Yeah, the immutability of it is another issue. In other words, you would use an off-chain solution to reference this information, and you would ask the chain itself, has it ever been changed, which I could deploy this many times with different data, and in that sense it has been changed.
You're referring now to an external solution like a blockchain explorer, so that you have the ability to check what happened.
Yeah. Yes, that would be actually well, okay. So then this discussion, that's approach number one. It was with the persistent send, and this name would be stored in the would be registered. And so I have a URI to it, and so you could look it up, and you could resend. Actually, you could compete with this. That's kind of a bad. I'm sorry to just think on the fly. Please jump in if you're just way ahead of my thinking.
So I think the simple way of doing this is just to register something with the data. So you get that, you pull the data. So the continuation could be, like when you supply like ACK, register ACK, you get ACK back. And so ACK could just be the set of processes. ACK could be the data itself. And so you just register name as the thing.
Right, but I don't know how I would know that that was never changed.
Well, registry, I don't think would allow you to change it.
Yeah, insert arbitrary will not allow it to ever be updated.
Yeah.
Right, okay. So what you're saying is this name would still be insert arbitrary. You would not do the double send. You'd actually listen on that name for an ACK. And so anybody sending anything on that name, let's see if I can just do. So for anything, actually it's no. Is that what you're saying? Deploy. Sorry, I know this really seems really simple, but at the same time, as I've tried to design this, this very simple thing, I don't have actually truly understanding the real meaning that I get from an application if I were to use this.
Mm.
Okay, and I'm sorry for intercepting here. I have the feeling that we should address this the next call. Then, if this is fine, Ken, sorry. As the main topic today was scheduled for
yeah, no, I understand. You were asking for alternatives. I thought that was.
Yeah. Let us put that in the backlog. That's a question I have as well. I would be interested to.
Yeah, we can also try and schedule a breakout session if this is something that's where you would benefit from having another person to bounce ideas off of. Glenn, I would suggest. But we can talk about that at the end.
Yeah. That's what you were asking.
Okay.
Please.
Just as a heads up, Dan, there was some confusion about double minutes. You have the right one now in the chat, and we have a unified document now. And do we have other interesting topics, like a short intro to a topic you like to address maybe next time before we close the intro session? All right. Okay. Because we are running late already, I would say, Theo, I would be super interested in what you like to share today about our main topic.
Yeah. So the topic written down isn't quite what I would frame it as, but it's related. The general, I guess, topic would be exploring the different model in Ethereum, which I think is a pretty understandable conventional system in RChain, and what the difference is and what that means for designing things inside of it. And then tying that into the question of kind of what is a token at a very general level, and then how did that apply to Ethereum and to RChain. So the main difference, you could say, or a main difference in RChain and Ethereum is that there is no concept of an actor within the system of RChain. Within Rholang, of course, there is no actor. You can have names, and there's a relation between that and the actor concept, but there's no real concept of an actor in the way that there is in Ethereum. And the way that I'm defining actor as, it's something that exists outside of the main part of the system that has agency within the system, and describing agency as the ability to affect or initiate a set of changes within the system. So for example, in Ethereum, there is, like the Ethereum data structure is a triple, where you have state, you have balances, and you have code. And there's two different kinds of accounts in Ethereum. There's user accounts, external accounts, which are private keys, the public key of which is the account address. And then there's contract accounts. And all transactions in Ethereum originate outside of the system. They all originate with signed transactions submitted by contract accounts or external accounts. And external accounts don't have any code, they just have a balance, but they can send a message, a signed message to a contract account or to another external account. And if you send one to a contract account, it'll look if there's a, the address of the contract account is derived by the deployer, which is either a contract account or external account. And the message is sort of you see is there code that's associated with this address, and then that code operates over the state associated with the address, as well as the balance. And so that kind of, the model of building sort of systems or programs in Ethereum is pretty simple, because you always have these signed messages, and the signed messages have the property of the sender. So who is the most recent sender of this message, and also the origin, which is what is the external account, who is the agent that initiated this transaction chain. Now, if you were to think of this as an object system, it's basically one in which you have actors, and any actor or any contract, any node in the system can forge the address of any other node. And the way that you do access control in Ethereum is basically by like access control list kind of model. And you could do other kind of twerks, but it basically comes down to looking at the message, looking at who sent it, which is the identity of the contract or the identity of the agent or the actor that sent it, and then making a decision based on that. Now, to compare that with RChain, there is no really outside to Rholang. And so what RChain is doing is they're sort of fabricating this external boundary, right? Because the reference is everything that lives inside the system can't be manufactured and can't even be exported outside the system. So the RChain registries serve as a way to cross this boundary, to enable agency by an actor that lives purely outside the system within the system. So it's kind of like an artificial construction of what is an agent, what is an actor. And the answer is basically use these registries, right? So the registry allows for an entity outside to map an internal name to an external forged one. And so that kind of makes some things a little complicated, because you don't have this native understanding of an agent or of an actor or of kind of an identity. You also don't have a really clear way of serializing internal structures outside. So that's another component, another thing that you have to think about is what is the way that you serialize, for example, a mint or a purse, such that it can be communicated and read by some kind of client. And that's not really been an addressed question. The other thing is, how do you actually reference a token? And so it's important to talk about what is a token. And the framing that I have which I think applies to all instances of tokens, is a token is an encapsulation of some kind of right, perhaps, but really what it is a projection of a process. And the value that is afforded to the token depends on the ability to reason about the provenance of the token and the integrity of the process that created it. So a couple kind of simple examples. Subway token, right? So the machine, the subway token is imprinted with the mint, right? That shows it's from the subway, and that means that you can trust it as a subway token. And the machine reads the token when you put it in based on the weight or something. And yes, you can forge it if you wanted to, but it's not really worth forging subway tokens. Another example would be a US dollar or any kind of dollar, right? So the dollar is a projection of a certain process. It's the monetary process of the state. The integrity of that process depends on basically the infrastructure, the trust infrastructure around it. So the legal system, the military, the governments, all that, right? So that provides integrity to the process that issues the dollar. And then again, tokens can have both intrinsic rights, perhaps, but also extrinsic afforded rights. So the intrinsic right of the US dollar is, well, it's, I guess, US debt. But if you go back a few years, the intrinsic value of the dollar is that you can convert it into gold. It was sort of a placeholder for gold. Now, the afforded rights of the dollar are all the offers projected onto the dollar. And they're able to project upon the dollar because there's a way of validating the artifact itself. You can look at the security measures. And by extension, you can see where the thing came from. So like old coins used to actually have a mint mark on them. And that was because if there was some irregularity in the printing of the coins, you were able to trace it back to the exact mint. And so you're able to correct the process that created this. So it's a similar kind of thing for crypto tokens, right? Where you have some process that is projecting some artifact. You know, for example, Bitcoin is an artifact of the process of the Bitcoin protocol. Now, Bitcoin is not just the protocol that's running, it's also the entire social system around it. Now, the Bitcoin itself actually encodes the integrity of that process in itself. I mean, you can't really forge proof of work, but also requires a social evaluation of understanding how rare that proof of work is. What is the conversion from energy into actually being able to create that coin? But it's the same kind of concept. Now, in Ethereum, there's sort of another level that's introduced where it's like, what is an Ethereum token, right? Well, all an Ethereum token is a piece of state that lives at an address. And it's a piece of state that lives at an address with an interface that's recognized. I mean, that's a token. It's nothing special, it's nothing magic. It's actually really stupid when you think about it. And all of the value that is projected on that token is, well, it's the narrative around it, but what it comes down to is there's an expectation that there will be some future offer or some present offer made against that token. Now, the integrity of the process is ensured by the fact that it's running on Ethereum. So that's pretty straightforward. And by having basically the rights that you have, it's a centralized structure, right? So the rights that you have are, if you have a name, if your address, the sending address happens to be on the key side of this map, then you have the right to modify that balance. And so it's sort of a recognition of a right, even though the token, unlike the dollar or unlike the Bitcoin, it's not actually going anywhere. It's all sort of in one place. So it's sort of more of a narrative form. So what does that have to do with RChain? Now, keep in mind that this definition of a token is that what you're projecting value onto is the ability to see where a process came from. So in Rholang or an RChain, you might use, for example, the make mint pattern. Now, what is make mint? All make mint is the value that's being projected onto a token comes from being able to identify where that token came from. Now, the token in Rholang, in this case, is much more token-like in the case that it's actual bearer instrument. So that token actually changes I guess, context, right? Like, make a wallet context. It changes context, as opposed to the Ethereum token, which doesn't change anything. It's all in one sort of ledger. But really what you're doing is when you're saying, for example, when you have one purse that's trying to deposit another purse, the question that they're trying to answer is, what is your source of origin? Is your source of origin this same point? If it is, then you do it. If you're making an offer against, give me, 5 gold tokens and I will let you have access to my data, or I will create some contract for you, provide some service. What you're trying to ask is, I'm looking for a projection from the mint that I'm calling the gold mint, right? And the reason why this presents a kind of challenge is that if you want to be able to make an offer against a token, or if you want to be able to, from the outside, reference a token, the way you do so is by referencing its provenance, where it came from, the mint that created it, and to extend that, maybe the forge that, or the factory that created the make mint thing, right? So it's being able to trace back that to, okay, here's a reliable source of mints. Here's the mint that I'm speaking of. Here's the purse, and I can trust that this purse is the purse that follows the rules and the interface, whatever that I'm thinking of, because I can trace that path back. And so the challenge is that because we're talking about Rholang, and the current sort of definition of the mint contract is that if you know the name of the mint, then you have access to the mint, and you can create as much purses as you want. And so the challenge is, how do you create a system of referencing both internally, if you had sort of an offer contract that you're saying, I'm going to exchange this mint or this token for that token, but also externally, how do you reference something that can't be serialized across the boundary of the system? And those, I see, are the two kind of main issues. And there's a few ways around that. One of them is you can reference things by the I call it fingerprint, but it's the bundle EQ of a process. And so you can pass that around as a referent, such that when you get a mint, or when you get a purse, you can check that, or you can sort of advertise an offer as, I'm looking for something that descended from this mint. And you can reference the mint directly, and then if you have the mint, you can verify that it's the same thing, because you compare the bundled one with the unbundled one. And you can do that for kind of purses and other things as well. So that's kind of one idea. And another one would be that you create some kind of structure that is able to mediate between all these things. That is sort of a trusted party. Right now, this is in a Rholang contract, so it's not actually, it's sensible to trust it. That would basically act as the thing that is the intermediary between the mint. And so you can have an interface, a wrapper around a mint that is publicly exposed and publicly referenceable, that allows you to, for example, get the identity of the mint, get the name of the mint, things that can be serialized and sent outside the system. That would allow you to spawn a new purse, right, with 0 balance, right? And then you sort of build up these wrappers around the conventional structures of the mint and the purse that allow you to reason about them and communicate about them without exposing the underlying objects. So I think I'll kind of leave it there and open up for whatever kind of discussion you want to have around that.
Thanks a lot, Theo. Like, my first question would be if you can like elaborate, or if you have any specific ideas how we can generate those fingerprints.
Well, the fingerprint for the mint would just be the bundle 0 of the mint.
Okay.
And then even using the current interface, like you can trick a purse to give you the bundle 0 of the mint. Because if you, I mean, hopefully they'll fix this, but if you ask it to get the get decrement, but you pass it in like a fake or mocked source purse, then it'll return the bundle 0 nil of this mint. So it's actually a way of extracting the mint out from the current implementation of the purse, which could be useful, but probably not desired behavior.
I thought the point of the bundle 0 was to prevent that kind of destructuring. If it's bundle 0 of that unforgeable name and then nil, we can't extract just that unforgeable name, right?
No, but you'd be able to, if you're looking for like what is the identity of a purse, and you can extract out bundle 0 of this mint, and that can serve as that identity, or sort of like what is the type of this purse? Because otherwise, there's no way of comparing one purse to another purse. So the only way to
Okay, I think I understand. You're saying like we can use that bundle 0 as like in order to reference it in a wallet UI or something like that, but not to actually mint coins. Is that what you mean?
Well, actually, I don't know how well it would serialize outside, but in order to reference it inside of like an offer, like in the system, if you want to make an offer of this token for that token, how do you sort of specify the type?
Oh, yeah. Okay, I'm with you now.
Am I audible? Hi, this is Dan. Am I on?
Hey, yeah.
Yes. Hey, Dan. We can hear you.
The way to test whether two purses are from the same mint is you spawn a 0 balance purse from each one and deposit it into the other.
Right. Yeah. But if you were to if you want to have like a registry of here's a bunch of purses or here's a bunch of like offers, and you want to be able to specify what is the kind. Now you could do it in terms of the purse, right? But the question is like, what if you wanted to say, what if you had like a registry of here are all the offers, and you're looking for what type of offer is this? You could match against the bundle 0 of the mint as the type of the purse, right? Which you can just like pattern match, as opposed to having to retrieve the object and then try to do a back and forth a deposit. But yeah, that would be another way of doing it.
So on Ethereum, the tokens had some, arbitrary text strings like a name and a symbol, and those are probably easy to implement at the mint level. But they also have total supply. This is like ERC20 stuff. That's total supply, and that's real easy when you have a central list of accounts. But when you have purses going all over the place that are disconnected from each other, that idea of total supply. I don't know if we're breaking the model if we just record total supply at the mint level.
No, I mean you have a central issuer of all the tokens. So I mean, fortunately, you don't have to keep track of all the ones that are floating around. You can just keep track of all the ones that are minted, and then set a threshold and limit that.
Mint contract, right? Well, at least to make it straightforward.
Sorry.
One could perhaps do that forensics now, although it looks challenging. But if one wanted to do this straightforwardly, we would want to change the mint contract, right?
Yeah. Well, you can either change the mint contract, or what might make sense is to just put a wrapper around it. I mean, I think we really should try to stick like all the primitives in principle should be like e-rights kind of things, right? Because those are, how to compose those together. And so you can wrap an e-rights flavored mint in something that only allows certain kinds of access. So you can set a limit on how much can be printed or whatever, and then just use that as a kind of like a outer shell. And that would allow you to have sort of a consistent core of all the cores of all the mints look the same, but then you have different kind of flavors wrapped on top.
I wonder if you can, okay, yeah, the purses can't increase.
I'm sorry, Dan, would you be able to get closer to your mic? I'm having a hard time.
I'm using a headset thing. It's hard to imagine getting closer. Is this better?
Yeah, that is.
Okay. I was just wondering if, if people with individual purses could cause the wrapper that keeps track to get confused, but I suppose they can't, because the purses conserve the amount of tokens. They can't like make more or less.
Yeah, and I think the same pattern would apply to purses. You can wrap purses however you want with a different interface or a different kind of thing.
Like basic wallet.
Yeah.
Regarding keeping track of balances, I have like two things in mind right now. If we don't keep track or send that we send a transaction to another purse, we will not see that, right? So we need to track that in the form of, say, a message which is sent, for example, to another process which records all the transactions which happen. Is this correct? Or would you say that by default transactions are not traceable? It depends just about the function if we track them or not. So if I'm sending from one purse to another purse, if I'm not sending additional com event, or I have like a way to signal that I sent that, it will not be visible in a central place. So we will not have transparency about flows of token. I mean, this is desirable, but it's also desirable to have anonymous transactions. I'm just trying to wrap my head around how this will look like, how a transparent token would look like, and how an intransparent, say, anonymous token would look like. Maybe you can elaborate on that a little bit.
Yeah, it's a good question. I haven't really thought too much about it. I wonder if Dan or someone who's been more in the weeds of RChain knows if you can monitor like the tuple space for certain kinds of events, and then use that to track kind of wallet balances, stuff like that.
Yeah, so I think this is perhaps the major challenge is that, yeah, so there's wallets where, you know, there's a signature for everything that happens with a wallet and stuff, but with purse, if you go down to the purse level and you're sending stuff around, there's no signatures or anything, and I don't know what, you know, counts as like the transaction ID or anything like that, or how you do like a blockchain explorer, you know, or something that keeps track of all the balances. So reconstructing those where everybody can see everybody's balance and stuff like that, I'm not sure that, I don't know how we're going to do that. Maybe it's easy, but I don't know.
If I'm sending something from one purse to another purse, and I want to have that transparent, might there be a way to send a com signal, so a message to in the direction of the mint? Might be a separate function close to the mint contract, where I just, you know, then log that I send from this purse to another purse.
Well, so to me, the straightforward way to make things transparent is to use the basic wallet thing. That seems to have the same functionality as Ethereum. But if you use the lower level things, I'm not sure what happens.
Theo takes a little bit more time. Yeah. Okay.
So I was messing with the purses yesterday. Something that was kind of bothering me was I know with gRPC we can do a listen for data at name, and I wanted to use it so that I could check the balance without having to make a transaction. I wanted to somehow expose some channel continuously from inside the purse so I could see the balance, and I couldn't sort it. But it feels like, you know, with Ethereum, you've got the idea that you can call and it runs some smart contract without creating a transaction, or you can execute, which will create the transaction. Something where we can read, you know, from a smart contract with some sophistication without having to make a new block. Maybe that's a feature request, but this idea of exposing a channel continuously that lets us see the current balance on a wallet, or on a wallet or a purse, it seems like something that would be valuable.
Yeah, Joshy and I have been scratching our heads over that. It's in the issues list for RChain API.
That's a great question.
One thought that I have is, you know, I think we maybe have different levels of comfort with like modifying the existing purse or wallet contract. My comfort level is if we can make fairly simple improvements that add features and push those back into core, I think that's an okay thing to do. And if adding an unforgeable name to each purse that just like contains its balance, and every time it receives or sends tokens, we update that channel, then listen for data at name will do exactly what Chris is describing. I would be comfortable with like, you know, us writing that up. And if we get a really basic POC wallet working, making a PR back to core and saying like, here's a little improvement to your purse that allows features that a lot of users are going to expect.
Well, I mean, I think we should be fairly comfortable making whatever modifications we want. The issue is that we should try to have the core of it follow kind of the eWrites abstractions as closely as possible. And then we can decorate however we like and not use anything underneath, but at least have that as a base. So is there any way of listening to events on the RSpace then? I don't know that.
For data at name. That doesn't, oh, for listening continuously. Yeah, they haven't, I don't know why the API, the gRPC API is called listen for data at name. So you would think you would issue that call and then just sit back and they would tell you when something happens, but that's not what happens. It's currently a polling interface, which is bizarro to me.
And that wouldn't be a forgeable name though, right? That'd be like a registry name or?
Forgeable or unforgeable?
It's any name.
But how is the name serialized?
Yeah, the trick is getting the ID for the unforgeable names. That's not, Dan and I have been sort of starting to think toward that, but it's hard crypto kind of thinking to figure out how they're coming up with those IDs for the unforgeable names.
Well, to predict them in advance is hard, but to just scrape them off the chain is straightforward. It's a data structure just like a string or an integer or something.
Oh, I see. So you can listen to it if you're able to find the name. You can listen to it from the tuple space, but then you can't reconstruct the name to send back into the system.
Right. You can't write a Rholang program that has that name in it. Right.
Yeah. Okay. Oh, that's interesting. That could actually work pretty well.
But let's just talk about the actual experience of how that would work for a second. Dan, if I understood you correctly, you're saying it's easy to write code that will print an unforgeable name to standard out and it will tell you the hex ID, but then that requires someone to be watching a node log and telling you, or a program to be monitoring the output and grepping for things that look like unforgeable names, right?
Well, the off-chain thing would be doing the gRPC listen for data at name, or it would be doing show blocks and stuff, and watching the chain. It wouldn't be looking at the node logs.
Yeah, but if you've done a new on a name and then you want to get its ID,
Yeah, you have to send that to some registry. You have to do that via the registry. Yep, yes, all off-chain things start with the registry.
And so, yeah, can you go from a registry URI to something you would see in show blocks? And what's the pathway to make that connection?
Yeah, that's the issue that we've opened in RChain API and started scratching our heads over and not gotten to the bottom of yet.
Yeah, I was following that, and I think it led to Kyle's presentation at RCon 3 about the deterministic aspect of that. You can determine what the name will be. You just can't create an instance of it given that ID.
So I haven't really looked into this. I haven't even looked at RSpace, but would it be possible to do something like this? You write a program, you get its hash, you register it, and then it will register it at some unforgeable name, but with the known hash. And then if you're monitoring the RSpace, you can look for something that is, because the registry events are public, they're forgeable, right? And they'll stick out. You're looking for a registry event with the hash that you provided, and then you can get sort of the name that was created when it was deployed. And so when you have the name, you can look at the actual space of the contract and then just look at what the balance is based on that, and if it changes.
That's the rough sketch, but the details, yeah, I'm not sure.
Yeah.
So can you try to repeat that? I tried to wrap my head around it. So if I understood, you write a program, you generate the hash, then you register that, and you will see say the name, the unforgeable name plus the hash. so you know where it is. And if you want to load the balance, I thought you need a second like unforgeable name, which say it just gives me the balance.
Yeah, so the idea is just to read the balance always from the location of the contract, which you can read from the
Fine. Okay.
So as long as you have some way of figuring out what that name is. You can't reconstruct it in the system, but you can monitor the R space because all this state is public. So you just need to know kind of where it's living. And it'll just be the, like R space stores it in terms of like continuations and keys. So as long as you know the name of the key or the continuation, you can see it. As another note, the pattern that I've been using is like is introduced as like the database pattern, or like you're sending stuff. Ends up being a very, very useful thing for creating what are like Rholang structs. And the nice thing about them is that if you're using strings as the keys for it, then those keys always can be serialized, and they'll stick out in the R space. And so it makes kind of reading through logs and stuff like that a lot easier because you can see sort of like the values mapped directly to the keys. And it could be useful for like serializing stuff and sending it out as well.
What always helps for me is if I have that visual. So I think I grasped an idea about it, about the concept you proposed. But I would be very interested if we can say, maybe if we have different proposals or if we have the same proposals, but to sketch that out. And I think to speak about the flow and like the dependencies and so on, this would help me to fully grasp it, and also to push in a direction where we might be able to try it out.
Just from my understanding, the blessed contract. So you've got make mint and you've got basic wallet. Am I understanding correctly that those are always available? If I wanted to make a basic wallet, I don't have to deploy that smart contract myself. I can somehow just create an instance of one of the blessed contracts.
Correct.
Those blessed contracts are all factories. So you just send the parameters to the, like, it's called make mint because it makes mints. So you send the parameters that you care about and you get back in return a mint. Does that sound right?
Yeah, totally. Would I use the literal name make mint, or would I need to somehow look it up in the registry or unforgeable name or something like that?
Yeah, I think, well, that's a good question. For a long time, it was just on the forgeable name @makemint. I think they're trying to switch those to registry. So yeah, you'd have to like look it up in the registry and then call it.
Do you want me to show you?
Sure.
Okay, I'll do this. Ooh, Inception. Okay. I always forget at this point. Casper, Rholang, Mint, I think has got, yeah. So here's them going through the computation of how you construct an unforgeable name ahead of time, given things like deploy parameters.
Do we have this?
Sorry?
We don't see your screen, Dan.
Yeah, do we have a screen share?
Try again. Oh, I see. It's waiting for me to. How about now?
Yep, good.
Okay. So I'm in Casper source main Rholang makemint.row. I guess you can see that here. So they go through this computation of building an unforgeable name because they have to sign it. And this is done at design time. That timestamp is probably, the programmer looked at his watch roughly. And so that's the name of makemint. That's the registry name anyway, which you can look up makemint. I think there's even a test that does it. It's probably part of this commit.
We need a registry to go from URIs to nice names.
That's partly a joke, but actually quite serious.
Yeah, it is. And if anyone wants, it'd be a good topic for some of the time, like the looking at the ENS model.
Yeah, absolutely. Good point, Theo.
Somebody make a note of that, please. Okay, well, there's a test that shows looking up the make mint contract, but I don't see it right away. Maybe if I went into source test. Yeah, so here's how it looks up the make mint. Yeah, that's a lot of ceremony to import a contract, but there you go.
I imagine they'll have something cleaner by the time it launches, but and it doesn't look like they're actually making and they'll probably have like a blessed subset, and the only difference between blessed and not is that you don't pay for it, right?
Yeah, why would you think that it's going to be cleaner? I mean, they might have development tools that allow you to, that will autocomplete these things or something, but as far as what goes on the chain.
Well, why wouldn't they use the normal registry?
This is using the normal registry.
Lines 13 and 14 are registry lookups through the regular old registry.
Oh. Well, what I'm saying is I imagine that for blessed contracts, it'll be row blessed make mint or something.
Well, I guess that's a possibility.
But that's like super silly in my opinion, because then what's the difference between doing like, new make mint from row blessed make mint as opposed to just using a regular old forgeable name?
Maybe it would be a bundle 0 or whatever that you can't screw with, you can't listen on.
Okay, yeah, that's a good point.
Bundle plus or whatever.
Can you guys imagine a way to, I'm considering RChain API here, but a way to do a deploy and then not propose a block, like just run some smart contract and then throw that away, throw the state change away?
My instinct is that seems super useful. Although I can't put my finger on a use case quite yet. It just sounds appealing. What are you thinking of using that for, Chris?
I made a whole bunch of smart contracts that were for tokens that had decaying value. They decayed in all these different ways. And you don't actually want it to update the state. You want the decay to be dynamic. So like imagine it's spendable value. So you've got 10 units, but it's only worth 5 because, it has a time decay and it's 5 units have decayed away. So you don't update the state, you just say, what's my current spendable value? Or let's say it's a GPS decay, where it goes to 0 at the edge of the geofence, but at a certain coordinate, it has max value. So it fluctuates up and down. You just say, give me my current value. And you want everybody to know how that value is computed. So it's in a smart contract that's shared.
What do you mean by update state?
I don't want it to update the blockchain.
He doesn't want to submit transactions every 1 minute or 1 day or whatever the threshold is that changes some state that contains its current spendable value. Is that what you're saying?
Exactly.
Yeah, because this would always create gas costs. In addition to that, the question is, how do you reference the time? So this would require that you know how much time passed and how do you oracle that.
So if I could just compute it using a shared contract, so everybody computes it the same way, but it doesn't update the blockchain. I've implemented these ideas on a couple other blockchains, and I just always had that functionality. I could run a smart contract without making a new block.
Yeah, I'm starting to just brainstorm or like think out loud about solutions that involve like you running your own node and it doesn't publish the blocks it creates. It just throws them away and rolls back state. I mean, that doesn't seem like super hard to do if you're someone who knows the language that the node's written in. I don't think it's implemented in the current node though.
I think that's a great idea, Joshy. But it gives you the ability to do that and to run it locally. But you would need to do that for every request if you yeah. Oh.
It's an idea. These are certainly edge cases for what we could do with tokens, but it might be something that I'll dig into deeper at some point.
Would you be able to share the descriptions of those or the code of those contracts?
Totally. Yep.
Do you like to publish them in the doc as well?
Yeah, those are super interesting ideas. I'm also excited about looking at your code.
All right, we're coming to the end of the session. It's like 3 minutes left, and I know that some people have different directly meetings afterwards. So yeah, I have the feeling that there are a lot of open questions right now, and I try to also wrap my head around the details. What do you feel, guys? Is this something valuable if we continue in the next session again about like what are our like shared understanding, how it changed, and what are our new ideas there, and maybe some sketches about potential ways how we could represent the wallet in the smart contracts?
We're at the point where, you know, staring at code and stuff like that is you know, we got reached kind of the limit of talking about it out loud. So I'd like to know where's our shared scribbling space for the next week? Does that make sense?
Yeah.
In writing work.
And is there a channel that like EU, Rholang, or whatever the wallet channel could serve as this and just dump code in there and then have that as a basis for the conversation? We can draw from that for next week, or?
I think that's a great idea. Let us follow up on that. I don't know which channel is the best one at the moment. If you don't have an existing one, we would need to create one.
Yeah, but if we don't have some shared channel right now, then we can't follow up.
Yeah, you know, we can send an email with the shared channel, but you can propose one. Do you have a proposal?
My preference would.
I don't know who controls the Colab server, but I think it would make sense to have a channel over there. But I literally don't know who can create channels there.
Well, we don't need to create one. There's a Rholang channel. It's perfectly fine.
Sounds good to me.
That would work. Okay.
All right. Then we have one, the Rholang channel on the Colab server. Does anybody has the Colab server access, or does anybody like still need access to it?
Oh, by the way, I think I actually am an admin of Colab.
Oh, congratulations. Do you like to create a new channel, Theo?
Yeah, so I'm happy to use Rholang though. I like being efficient with channels, but.
Okay, I think that's the best idea to follow up there.
You'll see the invitation there?
Yep.
Okay.
Yep. Thanks for posting it. All right, let's follow up in the channel then.
Yep. Okay. One last thing. If anyone has any ideas about how to do Rholang on WebAssembly, please ping me. That's all.
Great topic.
Yeah, I think that's quite advanced still.
Yeah.